Hi guys, previously we covered how to use input and how to use collision detection. Now we're going to combine those two things as well as the assignment code base to do something. In particular, we're going to add some new gameplay mechanic. We're going to add the ability to shoot projectiles in this platformer game so that we're able to defeat the enemies in the level without having to go over them. So to start, we're going to pick this token and we're going to turn this into a projectile because we don't want to introduce any new concepts per se. We're going to use what we've already learned and possibly look at some of the things that are going to be new to the editor and also the code. From that perspective, what we want is to utilize as much as possible of the existing code base. So what I'm going to do is drag this over here and turn it into a projectile. You can see that this game object is selected in the hierarchy. We're going to rename it by clicking F2 to projectile. I'm going to leave it here off screen because we'll be using it almost like a prefab as a template. We haven't looked at prefabs just yet, so we'll use the quick approach to simply copy this game object, instantiate it somewhere else, preferably in front of the player. And then we're going to add a custom component to it that will move it in a given direction. And if it hits one of those things, which we call enemies, both the projectile and the enemy die. So the context is reasonably straightforward. Now we need to add some stuff to it. And we're going to do that via a custom component. So if you go to the assets directory and open scripts, we can add a custom, I suppose, a new folder by just right-clicking and then create folder. I renamed it to z_custom because I want it to stand out. All the new stuff I'm going to add into that directory. That makes it easy if at some point we break something and we want to go back, then I know that all the things that we've added will be in this directory. Because if you look inside the existing directories, you can find that there's quite a lot in terms of existing scripts. We haven't gone through them yet, so we need to make sure that we don't break anything before we touch them. From that perspective, it's really nice to have a separate directory where we can just work and add new stuff. Think of it as a sandbox. In here, right-click, and we're going to create a C# script, which we're going to call ProjectileComponent. Double click on that. That should open Visual Studio. And while it's doing that, let's have a look at our projectile and see what stuff it has. Okay, Visual Studio is kicked in. Let's just increase this. Okay, so this so-called projectile has a bunch of things associated with it. So you might remember we did a Blocks Collider 2D last time. This is Circle Collider, pretty much the same concept. And a common skill among developers is to read the existing code base, be able to copy the existing code base and then modify. And that's how you learn about existing APIs, new APIs, and so on. It's a really powerful skill once you've got used to it. So we'll try to look at what already exists, see if we can find a pattern between what already exists and what we're trying to add, and then reuse potentially the same code if possible. So from this game, we know that the player is able to run around and collect these tokens. So there must be some kind of a collision handling already present. We can see that there is only one script that is attached, which is token instance. If you look inside mechanics, you can find the token instance script, and inside it we can also find onTriggerEnter2D, which is the thing that's called when this game object collides with another. And what we're doing here is, so if I open this in Visual Studio, we can see it clearer. We're getting the component of that game object, and the component type is player controller. So we want to see if the game object that collides with the current one has this controller by checking if it's not null. If it isn't, then we call onPlayerEnter, which is this piece of code. There's some stuff happening there about collecting coins and so on, but we don't really care about that too much. This is the important bit, that we're able to detect what kind of object it is. So let's also look at our enemy. This is the closest one, so let's pick that. There's animation controller, but I doubt this is unique to our enemy. This enemy controller sounds promising because it has the word enemy in it. So I would assume enemy controller is only attached to enemies. And there it is inside mechanics. So we can use that as a piece of information that will allow us to determine if the thing that we collided with is an enemy. And now what we can do is just copy and paste this and then try to modify it. So what we've done there, we've copied similar behavior, and then we're starting to think, well, I kind of want a very similar behavior to that, but with very slight differences. One difference would be we want to rename this to an enemy, because you can't have the same variable name declared in the same scope. So we renamed this to enemy. This will need to be changed to enemy controller. And this thing needs to be renamed enemy. And then on player enter, we can just do something similar. Add on enemy enter. Rename this to enemy controller, rename this to enemy, and we have something that we can use, right? So we haven't really done much in terms of actually understanding what's happening. And that's an interesting skill that you're going to develop as you go along in your programming studies. It's just the ability to look at what already exists, make a connection with what you need, and then just do the same thing. Now let's actually read and see if what we've done makes sense. Other is the other collider. We're getting the game object associated with that collider. In other words, we're getting the game object with which we collided. And we want to know if the enemy controller is attached to that game object. If it's not null, then there exists a controller on that game object. And we call on enemy enter with this enemy controller not being null. So we can actually do something here. So what do we actually want to do? When the projectile collides with an enemy, Typically, you either reduce health of enemy. That would be a fancy way of doing something. But for now, one thing's done in a simple way. So we're just going to get rid of both game objects. This token instance is attached as a script to our projectile, which on second thought we should probably modify, right? Yeah, we're going to extract it. Let's create our projectile component, which we already have created, I think. Open that, and then just do the same. And then the code that was there, in fact it was like this, remains unchanged. We've not added or changed this file in any way. Cool. So all the new stuff that we've added is going to live inside the projectile component. Let's see where we take this from. Using platformer gameplay. Where does it actually live? Player controller. Platformer mechanics. There we go. Cool. So we don't need this bit anymore because this is what we've copied from the other token instance. All we need is just this bit, which is going to call on enemy enter. Now, going back to the question, what do we want to do? Well, we want to destroy some stuff. We want to destroy the game object to which this component is attached. That was easy. We also want to destroy the game object to which this controller is attached, which should be as easy as this. So what this says essentially is when the two things collide, the two things being our projectile and an enemy, make sure this thing is an enemy. If it is, kill both. Okay, let's go back to Unity. Let's find our projectile, which probably should live outside of the tokens group, but that's fine. And then we're going to add projectile component. Okay, so that was one of the things in terms of logic. Now we need to think about how we're going to actually make this move and spawn. Because so far we only have this one game object called projectile. We want to essentially clone it as many times as we want on some kind of key press. And what I'm thinking is we can create another component, add it to the player, that will check for input and then update the game world as needed. Plus, we want to probably define something like move speed and also direction for our projectile component. because these are the things that you need to know in order to move something. Now here is an important bit that will allow you to modify settings of your components within the editor. If you define a public variable such as float move speed, now we're going to set to 2 maybe. As long as it's public, it should be picked up by the editor, which will allow you to change the move speed or the variable that we've just created. And you can do that on a per instance basis, which is nice. So by default, let's make it 0 so that the original thing doesn't move, but we can update it as needed. We also said that we need direction. Vector, let's go with vector 3. Direction. It's going to be set to, well, just all zeros, since by default we're not going to be moving anywhere. And we should see the direction vector 3 over here as well. In update, what we want to do is move our game object towards, well, using that direction and the move speed that we've defined. We can do that by obtaining transform. We already did that, so you should be familiar with how to move stuff. We're going to take position and add direction, normalized, and multiplied by move speed. Okay, let's get separate. Does that give us? Oh, it actually changes the vector itself. Okay. So we've normalized the vector, which brings it to unit length, which is length 1. So if we multiply that vector by move speed, we're going to obtain a vector of given length. But now I'm thinking, if direction is specified as a unit vector anyway, or at least with 1 being to the right x-axis, -1 being the to the left on the x-axis, we don't really need to normalize it. We can just use that and multiply by move speed, right? And then multiply by time delta, so that we can get the frame time per frame. Make sure this happens first, but it should. And then multiply time, delta time. Oh yeah, by the way, if you're coming from Java, this is operator overload. It's the same as saying something like direction, multiply local, and then paths move speed multiplied by time delta time. That's more or less what this does. Okay, let's give it a go. Let's set this thing to 1, 0, and then this thing to 1 as well, just to check how this is going to move. too far, I don't actually see it. Move it over here, so it's within the viewport. Okay, that isn't moving, which is not great. Why is direction? That's odd. That's supposed to be 1, 0, and then 0. Why is it setting it to 0, 0, 0? Okay, so that's thing moving. That's good. Not sure why this thing reset to 0. That was odd. So we have the ability to move this, which is good. The remaining thing is just to make sure that both things collide, right? Well, we still need to spawn it on player command, and I think we're good to go. Just to check the collision stuff is working, I'm going to move it over here. And then this thing will start moving towards the enemy, which is over here. And then if they collide, both should disappear. If that works, then that's pretty much done. Nice. So now that our prototype is working, I'm going to move the template over here. Our DIY prefab. And then reset it back to 0. This thing is just 0. We can set when we set these values when we actually instantiate a game object. Okay, so the template is done. Now we need to add our new player component of sorts. Shall we call it player shoot component? Do you want to normalize line endings? Well, not now. Player shoot component. Okay. If input get key down. Yeah, we don't want to spam projectiles. Key code. Let's go with F. I'll keep the things here, the curly braces, for consistency. Get key down. What we're going to do is instantiate our game object. And we need a reference to that, right? In which case we can just create a public game object. Call it a projectile template, which we're going to assign. And we should probably do that before we forget. First of all, we need to add the player shoot component to our player. Player. There's a lot of stuff attached to our player. Add component, what's it called? Player shoot. Yep, there is projectile template, which is currently set to none, which is like null. And we need to set it to our, there is a circular button, which you probably can't see in the video, but on the same line, if you just click on that button, this thing will open. And we'll need to select our projectile. There's only one because we renamed just this thing to projectile. Now that this thing is selected, if we go back here, this is going to be now initialized to that game object, which we can then instantiate. Okay, so what else do we want to do? This thing returns a game object, right? Yeah. So I've got a projectile. We've spawned a new projectile. We want to configure some stuff. First and foremost, we need to position it properly. And for that, we're going to take the player's position and we're going to add a vector to place the projectile in front of the player. Okay, I can already think of an issue potentially, because we need to figure out which way the player is facing. For now, let's keep it simple and then just spawn it to the right all the time. So the position is going to be game object. Actually, I can just use transform because the transform refers to the player's transform. Position plus new vector to the right. It's probably a vector 3 right or something, right? Yeah, but it's 1, 0, 0. Shall we add 2? Like 2 units? So that's going to move. No, that's going to position our projectile to the right of the player, regardless of where the player is facing. Next, we want to set up those values that we didn't, those ones, by obtaining ProjectileComponent. Projectile get component. I always start with lowercase because Java. C# is basically like Java, but everything starts with uppercase. Well, every function starts with uppercase. Interestingly, the variables still start with lowercase. Projectile component. Direction, was it? Yeah, direction is to the right, which is basically this. Move speed is, we used 1, it was okay. Let's set it to 2. And let's see if this works. Well, this thing is still moving. We might want to disable it. Otherwise we might run into issues where this thing disappears and then we don't have anything. Okay, F. Cool, I can shoot some stuff. Okay, we killed it that way, but that's fine. Let's kill this guy. Yeah, +2 is probably a bit too far. Okay, I forgot we can't shoot left. Okay, so our projectile is working, kind of. We need to tweak a little bit. Yeah, let's fix the left shooting bit, and then we'll call it a day, because there's quite a lot of stuff that we have gone through in this video. How do we know where the player is facing? Mechanics, player controller. Is there anything in here that we can use? We can use its velocity, I guess. Because if x is plus, then it's to the right. If x is minus, it's to the left. Oh, interesting. There is a sprite render flip X, which is being set to false or true, which gives us the two directions, right? Sprite render, do we have access to it? Sprite render. Okay, let's try that. No, it's this one. Private sprite renderer. On start, we're going to set it to what is it? Game object get component sprite renderer. Why is it underlined? Has inherited mem render. Okay, I probably want it to be renamed to something else then. Sprite render. Okay, it's happy now, and we can use flip X to detect direction. Okay. This thing needs to change, and this thing needs to change based on direction. Shall we call it value X? Just set it to something for now, and then if this thing, does it flip? Where is it? So flip X is false if we're moving to the right. So if not flip X, then value should be positive. Something like this. Else, I wonder if there's a way to just format the whole thing, because I'm not really a fan of these curly brace positions. So value X plus, and then this is minus, yeah, and then just use that, right? Value X, and then this thing is value X. Move speed remains unchanged, everything else stays the same. Let's see if that works. Nice, we can shoot left and we can shoot right. That's good. We'll need to do something with that thing because you don't want your template going anywhere. Apart from that, however, I think we've done quite a bit in this video. I'll highlight the important bits, which is once you create a new component and want to set something, a variable from the editor, then use the public keyword so the variable is accessible. We've already done input, so that should be reasonably straightforward. Instantiate is how you can create a new game object duplicate / clone from an existing one, and destroy is how you can remove game object from the world, so it's not in the scene graph. And also get component is how you can get your custom component or any other component attached to the game object. And on that note, I think we are done. Okay, I'll see you guys in the next video, and thanks for watching.